So we're in 35C. We're going to talk a little bit more about the distance formula. We touched on that briefly in the first part of this lesson. We're going to spend some time really looking at it right now. So the distance formula is a version of Pythagoras' theorem. So we know Pythagoras' theorem is a squared plus b squared equals c squared, where h is h, where c is equal to the hypotenuse, right? And we talked about this when we talked about the change in coordinate, where we had one point where we started and then we moved to another point. So we went from here to here, quite literally. Now, what we've done in the past is we have simply, let me switch colors here, we've simply drawn a right triangle and counted. I said, okay, that's a really bad triangle, but 1, 2, this is 2, and this is 1, 2, 3, 4, 5, 6, 7. So we know that our distance here was 2 and 7, right? And then we would just sub that in for A and B to find C. And we would say 2 squared plus 7 squared is equal to C squared. 4 plus 49 is equal to C squared. So that would be 52 is equal to C squared. Square root of 52 is equal to C, where C is the hypotenuse. All right, so then this would be the square root of 52, whatever that might be, whatever that would factor out as, I believe. The square root of 53. Hello, Miss Tracy cannot add today. For some reason, I looked at that and I was thinking, oh, this is 48. I don't know what I was thinking. Square root of 53, which can't be factored. So that's it. That's the answer. So then the distance here is the square root of 53 when we just do it with mental math. Now, if we wanted to find the actual length, then we'd put it in our calculator and get the square root of 53, which would tell us what that is. But for now, square root of 53 is a good enough answer. We could find the same thing without having to draw this out and count our units and then find the points. We can just remember what we talked about in our previous lesson, that change of coordinate. We can use that to find the hypotenuse. And we do that by using the change in x and the change in y, which is what gives us our A and our B. So let's look at that again. So we know that we start with the second point and subtract the first point. So the second point here, it can be either one, it doesn't matter. The second one here, though, is 4, 2, and the first one was -3, 4. Because we went from this one to this one. It doesn't matter. Length is always positive, so it doesn't matter. But we're going to use our delta change idea in order to solve this. So first we're going to find our A, which in this case we're going to say this is our A, and this is our B. So our A is going to be our Y values. So our A is going to equal 2 minus 4. And our B is going to equal, which is our X values, that is going to be 4 minus 3, -3, so it'd be 4 plus 3. Right, so we're going to take these changes and we're going to solve them. 2 minus 4 is equal to a -2, and 4 plus 3 is equal to 7. Well, length is never, ever negative, so that's a positive 2, right? It's always the absolute value of that. That's what it always is. So even if we took -2 and we put in Pythagoras' theorem, we would still get -2 times -2 is a positive 4, and 7 times 7 is 49. So you can see we get the same value by using our delta change formulas and finding the change in y and the change in our x. Now we can do this all at one time using the distance formula. And it's just a variation of Pythagoras' theorem. And all we're going to do is we're going to write it like this to start with. Our distance is our hypotenuse, which is C. and it's going to be equal to the square root of all of this. So we take our original change in coordinate for y, 2 minus 4, square it, because a squared, right? Plus our change in x, which is our b, so 4 plus 3, square it, right? Because b squared. And that equals c squared. But when we move the square off, it puts the square root over the numeric value that we got for a squared plus b squared. So we're just doing it in this format from the very beginning. We're solving for the distance without having to unsquare the distance later. That's all we're doing. We're unsquaring from the very beginning. So let's see if we get the same thing. Distance is equal to, this would be negative 2 squared would be 4 plus 7 squared would be 49. Distance equals the square root of 53. Fewer steps. This took us 1, 2, 3. Actually, it took us, we had to draw it out and then do this part first to get the legs. Then put them in. So we saved a whole bunch of time just by looking at the points, figuring out our A and our B. We didn't even have to solve it, right? We just said, all right, A is going to be, and it doesn't matter. Remember, we always said it doesn't matter which one you pick for A, which one you pick for B. So it doesn't matter whether you put in the X's or the Y's or the Y's or the X's. Doesn't matter. 4 plus 49 is the same as 49 plus 4 because of our commutative property of addition. So A can be B and B can be A, just as long as you keep the X's and the Y's together. You wouldn't want to say 2 plus 3 and 4 minus 4 because that would be messed up. You want to make sure you put the same coordinates together. And one of the easy ways to do that is just to write the coordinates on top of each other. If you do that, then it's like a little, you can just go right on top of each other, and these two go together and these two go together. And it doesn't matter whether you add or subtract. It doesn't matter whether you add or subtract. You have to subtract. But it doesn't matter whether you do the top minus the bottom or the bottom minus the top, as long as you're consistent, right? So if you subtract the top from the bottom for the X's, you have to subtract the top from the bottom from the Y's and vice versa. And to prove that point, we're going to reverse this and see that we get the same value. So D is equal to the square root of, so I'm going to reverse this, and I'm going to pretend that this is 0.2 and this is 0.1. And I'm going to say 4 minus 2 squared plus negative 3 minus 4 squared. Square root of, all right, that'd be 4 minus 2 is 2 squared, that's 4, plus negative 3 minus 4, it's going to be negative 7 squared, that's still positive 49. D is still equal to the square root of 53. Same answer. So it doesn't matter which point you subtract, as long as you subtract consistently. All right, and let's just do one practice problem here. And so we've got, let's see, we don't even have 2 points. We have 1 point and we have an example or a sample point. So we have 4 and negative 2. This is 35.6, by the way. We have 4, negative 2, and we have X and Y. Literally, those are the points. So all we can really do is write our distance formula. That's it. So we can say that the distance is equal to the square root of 4 minus X squared plus negative 2 minus Y squared. That's all we can do. That is our answer. Now, we could rewrite it a different way. We could write X minus 4 squared plus Y plus 2 squared, because a negative subtracted Negative times negative is a positive. So we could write it this way, or we could write it this way. Either way, we would still get the same answer. All right, those are our two possible answers for 35.6. And that is all I have for lesson 35. I'll see you in lesson 36.